Hi, hello friends. Welcome to T Academy. Let's continue the AP Transco 2019 AW paper solutions here. So in my previous video, I given solutions for the network analysis and the utilization of electrical energy. In this video, we'll continue the series of these AP Transco solutions. Now the area of subject is control systems here. Okay, the control systems is important topic here. So you see here. For the system shown in the block diagram, the transfer function C of S by R of S we need to calculate here. So here they given the R of S is the input, C of S is the output here, and here there is a summing point, and here also one summing point 1 by S into 1 plus S or S plus 1, and there is a one feedback loop here. There is another feedback loop here. So this problem can be solved by using two methods. The first one using the block reduction technique. Okay, and second one is you can go for the signal flow graph. So either one is easy for you. Okay, so now I will try to solve this problem with the block reduction technique here. So let's see the solution for this problem here. Okay, see. So here by using the property, what is the property? So there is a negative feedback system or positive feedback system. It's a positive feedback system here. So for a positive feedback system, see the formula here: g of s, c of s by r of s is equal to g of s by 1 plus g of s into h of s. Is a basic formula here. So here if there is a negative value, okay, so here is a negative, then means here is a positive, and if you have a positive here and here will be negative. Okay, so generally in most of the cases we will use a negative feedback systems here. Okay, so c of s bar of is equal to g of s by 1 plus g of s into h of s. Okay, next the r of s is a block uh, input here, and this is the output. So this is what we have done here, the same thing we have done here. So this is the same. So g of s by 1 plus g of s into h of s. Now here we are going to reduce this block here. So one block is 1 by s into s plus 1. By using this formula here, I will apply this formula here, and I will try to reduce this in this network. How I have done is, so this is nothing but our g of s, and this is will be h of s. Okay, so g of s nothing but 1 by s into s plus 1. H of s nothing but s. So substitute these two values into this formula here, then you will get g of s nothing but 1 by s into s plus 1 divided by 1 plus h of s into g of s. That means 1 into s divided by, so 1 into s divided by this entire part will come here. Okay, this is a reduction. Okay, then again, so there is a one feedback loop here like this. Okay, again one feedback loop is there. So again apply the same formula here. Now in this case, so this is will be my g of s next case, and this is will be my h of s. Okay, again simplifying this, how I have done this here: c of s by r of s is equal to, so g of s, if I simplify this, how I simplify this is, see here. So transfer function of this model, so I'm taking this model here. So g of s is nothing but 1 by s into s plus 1 divided by h of s. So I will cross multiply this here: s into s plus 1 plus s divided by s into s plus 1. So s plus 1 gets cancelled here. Okay, see here, 1 divided by s into s square plus s plus s. Okay, so this will be equal to 1 by s square plus 2s. So this is what I have here. Now there is a feedback loop here again here. So again consider this feedback loop here. Okay, now in this case h of s is equal to be 1. Sorry, h of s is equal to be 1 here. Again simplify this formula, 1 by, so now this will be h of s, sorry it is, and this will be g of s, sorry, g of s. Okay, so I will try to erase this here. So this will be, sorry, h of s, and this will be g of s, sorry. So sorry for making you confusion. I will write it again here. Sorry, g of s Now g of s divided by 1 plus g of s into h of s will is equal to 1 by s square plus 2s plus 1. Okay friends. So let's move to the next question here. The question is an open loop system is converted into a closed loop system having a negative feedback. The feedback path has a unity gain as compared to open loop system. The closed loop system has a property. So when an open loop system is converted into a closed loop system here. Okay, the negative feedback done. Okay, the ha feedback path has a unity gain. Okay, as compared to open loop system, the closed loop system is the following. So generally, just now you have seen the formula here. That is g of s divided by transfer function. I can say is equal to, so 1 I'll say plus or minus g of s into h of s. I can say, see here, when there is a positive sign here, the overall gain of the transfer function, overall gain, I can say gain here, okay, gain is going to be decreases. So by using this negative feedback concept, the gain is going to be decreases, means this is not the correct option. Okay, next one, bandwidth. We know that gain into bandwidth is nothing but a constant. Okay, see here, as the gain decreases, what about the bandwidth? So it should be constant, means bandwidth will increase, but here it is reduced here, so bandwidth is going to be increase. Okay, so this is also wrong option. Okay, so I can eliminate this. And next one, effect of parameter variations is reduced is the right option. Disturbance rejection capability is reduced. So we are using the negative feedback to avoid this disturbances. Okay, to use going to disturbance or noise cancellation, we can say. So this will also, the disturbance rejection capability is increased, it means correct option. Reduced it means is also wrong option. So correct option is effect of parameter variations is reduced. That means even though some changes in output will not much affect the output here. That's the concept. So answer for this question is C. Due to the presence of the feedback closed loop system, the effect of parameter variations is reduced as compared to open loop system here. So that's a comparison between the open loop and closed loop system. Next question, friends. See here. So this question, in the circuit shown below, the value of I of 0 plus and I of infinity will be. Okay, so this is a network given. The input is 2 into e power minus t into u of t. This is given in the time domain. There is a resistor, 1 ohm resistor, 2 farads is a capacitor, and this is a current flowing I of t here. Okay, so here the current value is for I of 0 plus, just instant after the supply, I of 0 plus, and I of infinity. So it depends upon the input here. Okay, so let's see the solution. So for this solution, I can see that the I of 0 plus means it is a initial value theorem. Infinity means I can say final value theorem here. Okay, let's see the solution for this problem. See here. So converting this e power minus t into u of t, okay, e power minus t into 2 u of t into its s domain form. So it's nothing but 2 by s plus 1 here, and 1 ohm resistor, and 1 by 2 s capacitors here. Okay, converted. Now I of s is equal to, just applying the formula, 2 divided by s plus 1 into 1 divided by 1 plus 1 by 2s. So simplifying this, I of s is equal to 4s by 2s plus 1 into s plus 1. You can do simplification here. And next one here, by applying the initial value theorem. So what is this initial value theorem says? I of 0 plus is equal to limit s tends to infinity s into I of s, the formula here. Okay, so limit s tends to infinity s into I of s. So limit s tends to infinity s into, so what is the s here? Already we have s here. In this case, s into, let me choose a tool here. Okay, s into 4s. So that will be come here. So 4s square divided by 2s plus 1 into s plus 1. Again, further simplifying this, applying the s is equal to infinity. So 1 by infinity is nothing but 0. So 1 by infinity here. So here also 1 by infinity. S gets cancelled here. So 4 divided by 2 plus 0 into 1 plus 0. So this will be equal to 2 amps here. So this is the initial value and applying the final value here. So final value I of infinity, what it says is I of infinity. Okay. So I of infinity is says that limit s tends to 0. Okay, observe here limit s tends to 0, s into I of s. So limit s tends to 0, so again this value 4s squared divided by 2s plus 1 into s plus 1. So as s value is 0, okay, so current will be 0 here. And understand here, so here we have changed the equation in terms of 1 by so that you can get the exact answer. But here there is no need. Substituting s is equal to 0, we'll get the answer directly here. So answer will be 2 amps and 0 amps. See, observe here. What are the conclusions that we can see here? So initially, observe here. So initially, the capacitor is act as what? It act as a short circuit for the supply, so that there will be a current or current of 2 amps. And after a long period of time, final value, the capacitor is going to be open circuit, so that the current will be 0. So that concept also you can apply here. So initially capacitor act as a short circuit here, and later it's going to be open circuit here. So similar kind of concept you have seen in our previous AP-TRANSCO AE network solutions, right? Next question, friends. A unity feedback system has g of s is equal to k divided by s into s plus 1. The steady state error in the output response for the unit step is. So this is one of the important questions of any TRANSCO AE papers. Either it may be TRANSCO, TS TRANSCO, or it may be AP TRANSCO, or somewhere any examination. The steady state error, one question will be there in steady state error here. Okay, one question will be there in the steady state error concepts in the output response of the unit responses, unit step input is, sorry. So options are A is infinity, B is 0, C is k, D is 1 by k here. So let's solve the problem here. So the given that the g of is equal to k divided by s into s plus 1 here. So this is of what? First order type 1 system here. Okay, so kp is equal to limit s tends to 0 g of s into h of s. Okay, so limit s tends to 0 k divided by s into s plus 1, where h of is nothing but 1. Okay, how we got this? When you substitute s is equal to 0, so this will be 1 by 0, 1 by 0, so 1 by 0 is going to be infinity. So kp value is going to be infinity here. Okay, and after that the ESS, steady state response, steady state error, so it is nothing but 1 by 1 plus kp, which is equal to 1 by 1 plus infinity. Infinity plus 1 is nothing but 1 by infinity only, is going to be 0 here. Okay, so answer is 0. Move to the next question. The open loop transfer function of a unity feedback system is given. G of s is equal to k into s plus 1 divided by s into s minus 1 into s plus 6. The system is unstable. So read the question properly here. It is going to be unstable here. Unstable, not stable. Most of the cases the question is they're asking stable. Okay, but here they given unstable. The students what they have done wrong, what they done wrong is they done the solution, but the answer is chosen as a wrong. Why? Because they didn't study properly. They say that it wasn't stable. They read as a stable and they done problem solution, but the question itself they're asking they're unstable. Okay, understand this. So the options are given here. Let's see the solution here. So by using the RH criteria, I can write the equations here. So first of all, g of s is equal to k into s plus 1 divided by s into s minus 1 into s plus 6. I will try to write the characteristic equation of this. That is nothing but 1 plus g of s into h of s. Okay, so 1 plus g of s into h of s is equal to 0. So this will be our characteristic equation. So from this h of s is nothing but 1. So substituting these values here, 1 plus k into s plus 1 divided by s into s minus 1 into s plus 6. Again simplifying this, we'll get this equation here like this. So what is the equation that we got here? S cube plus 5s square plus s into k minus 6 plus k is equal to 0. This is how we got. So this is what we got from the characteristic equation. So by using the RH criteria, I'm following here. So first I will take this s cube. Okay, so s cube having a odd terms. So first one is the odd term 1 here, and second one will be odd terms here, k minus 6. S square I will take even terms 5. After 5 there will be k here. Again cross multiplication like this. Okay, so 5 into k minus 6 minus k into 1 divided by k here. Okay, and after here we have a 0. Okay, so this is what we got here. Next after that, so 5 into k minus 6 minus k into k minus 0 into 5 divided by this value, so will be equal to k here. Okay, now as per the RS criteria, for the system to be stable or unstable, we need to calculate here. For a system to be stable, 5 into k minus 6 minus k divided by 5 should be greater than equal to 0. So this will be for stable condition. If I am taking here less than 0 means this condition is for unstable. Understand here. So I am taking less than 0, not a positive less than 0. So again simplifying this, you will get a k is less than 7.5. Therefore the system is unstable for 0 less than k less than 7.5. If it is stable means k should be greater than 7.5 is the answer. Okay, so next move to the question here. Okay, right. So this question is from the transfer function. Okay, a unity feedback system has the following unit impulse response. Impulse response C of t is equal to minus t into e power minus t plus 2 into e power minus t, t greater than or equal to 0. Then open loop transfer function of the system is given. So we need to find the open loop transfer function, and this is the transfer function which is a unity feedback system here. The options are as you show, as here you can see the solutions here. So first of all, C of t is nothing but the transfer function that is given in the question. C of t is equal to minus t into e power minus t plus 2 into e power minus t. So here I am using the Laplace transformation formulas here for your convenience, right? See here. Okay, so L into t into e power minus t is equal to 1 by s plus 1 whole square. So where t is there, there will be n plus 1 here. Laplace transformation of e power minus t is equal to 1 by 1 plus s. So I am using these two formulas here. Again, therefore, C of s is equal to, so minus t into e power minus t, what we can write, minus 1 by s plus 1 whole square plus 2 into e power minus t divided means 2 divided by 1 by s plus 1. So I am applying these formulas here. Okay, so I am applying these formulas here like this. Again, simplification, you will get C of s is equal to 2s plus 1 divided by s plus 1 whole square. But the given is r of t or delta r of t is equal to delta of t is equal to given. What is that? In case of the Laplace transformation of r of t, r of s is equal to be 1 here. Okay, now C of s by r of s is equal to 2s plus 1 divided by s plus 1 whole square, which is equal to g of s divided by 1 plus g of s into h of s. As a given it in the question itself, h of s is nothing but open loop. Sorry, h of s is nothing but unity feedback system here. Now g of s is nothing but it's a open loop transfer function. So from this simplification, we need to find this g of s value. So 2s plus 1 divided by s plus 1 whole square is equal to g of s divided by 1 plus g of s. So further simplification, cross multiplication simplification here, the answer is getting is g of s is equal to 2s plus 1 divided by s square is the answer here. Okay, move to the next question here. Next one. The open loop transfer function of a system is g of s into h of s is equal to 16 into s plus 1 divided by s into s plus 2 into s plus 4. The centroid and the angles of asymptotes are. So here the options are given. So let's find the solution for this problem here. Okay. So given that g of s into h of s is equal to 16 into s plus 1 divided by s into s plus 2 into s plus 4. So how many number of poles are there? S is equal to 0 is a 1 pole, s is equal to minus 2 is a 1 pole, s is equal to minus 4 are the 1 pole. So there are 3 poles are there, and 1 0, s is equal to minus 1 are zeros. So how many poles? there are three poles and one zero. Okay, we know the centroid formula. Okay, the centroid formula is nothing here, as you can see here. Centroid is equal to sum of real parts of the poles minus real parts of zeros divided by number of poles minus number of zeros here. Okay, so as you see here, the real parts of poles, there is no imaginary parts, only real parts. 0, -2, -4. So these three are added together here. Some minus of real parts of zeros. So again -1. So number of poles are 3, zeros are 1. So simplify this, you'll get centroid as a 2.5. So 2.5 is the centroid here. Okay. So next we need to find the angle of asymptotes. The formula for the angle of asymptotes here it is. So angle of asymptote is nothing but theta is equal to 2q plus 1 into 180 degrees divided by p minus z. So where q is nothing but 0, 1, 2, 3 we can take here. So theta 1 is nothing but angle of asymptote. Theta 1 is equal to 2 into first q will take it as 0 plus 1 into 180 divided by p minus z 3 minus 1. So simplifying first one theta 1 equal to 0. So 90 degrees here, 90 degrees. Theta 1 equal to 90 degrees here. Okay, so how many angle of asymptotes we need to calculate means 3 minus 1 is nothing but 2. So 2 is enough here. So theta is equal to 2 into 1 plus 1 into 180 degrees by 2. So which is equal to 270. So the angle of asymptotes are 90 degrees and 270 degrees. So from this the answer will be so minus 2.5, 90 and 270. The answer will be C is the right answer here. Next question, friends, see here. A system has a damping ratio of 0.4 zeta value given. The frequency response of the system exhibits a peak resonance of. So it's a direct for a formula based question here. So see here answer. Okay. So peak resonance. The peak resonance formula I have written here. So which is equal to peak resonance MP is equal to 1 divided by 2 zeta into 1 minus zeta square. So this is an important formula here. Okay. So MP is equal to 1 divided by 2 into zeta value 0.4 into square root of 1 minus 0.4 whole square, which is approximately equal to 1.36. Okay. In examination point of view, you don't have a calculator, but you have to memorize some formulas or some questions here like this. Otherwise, it's very difficult to get the answers, right? So see the answers here, how they are given. So 2.25, 1.36, 1.8, 2. So they are all closer together. Okay. So they are closer. You need to do some practice so that you will get the answers like this exactly. Okay. Next question here. This question is from the compensators here. Okay. A lead compensator GC of S is equal to 1 plus 0.12S divided by 1 plus 0.04S can provide a maximum phase shift of. So phi m we need to calculate, provide a maximum phase shift of. So this is also formula based answer. So let's see the solution for this problem. So here I have taken the GSC of S is equal to 1 plus 0.12S divided by 1 plus 0.04 into S here. And for a lead compensator, the transfer function as follows here. Okay, it is transfer function is equal to 1 plus Ts divided by 1 plus alpha into Ts here. By comparing these two equations, T is nothing but 0.12, alpha into T is nothing but 0.04. From this, alpha is equal to 1 by 3 here. Now, but they asked for what? They asked for the maximum phase shift. So for a maximum phase shift, the formula is like this. Okay, I'll move this a little bit. Okay, right. So maximum phase shift is equal to phi m is equal to sine inversion of 1 minus alpha by 1 plus alpha. So we know the value of alpha. So alpha is equal to 1 by 3. Okay, so phi m is equal to sine inversion of 1 minus alpha by 1 plus alpha, which is equal to 30 degrees here. Okay. Okay, next move to the question here. Okay, so this is the end of the session here. So next session we will continue with the electrical machine subject. Thank you friends. Have a nice day.